I just helped a client completely eliminate his entire staff and team of trainers by integrating this one AI feature and toolkit into his business. Currently, I'm working with another client who has eliminated all of his customer service staff from all over the world using this AI component. In this video, I'm going to talk about vector databases and how they compare to traditional databases when employed inside of a data strategy for one of the businesses that you're acquiring, doing due diligence for, or actively looking to scale and grow for an exit. Why is this important in the age of AI? Why is this something that you can consider? And what are the significant differences and advantages of having this sort of tool inside of your new business or acquisition?
Oh, have I got your attention now?
Hey there, my name is Adrian Monax, and a few years ago I made the transition from software engineer and AI expert to entrepreneur. And now I lead Rock Studios, a machine learning and AI agency that helps businesses that are actively in the process of acquiring other revenue streams or other businesses. And what we do is we go in, provide consulting, and show them ways that they can accelerate the due diligence process, cut costs, replace staff, and just overall optimize the scaling and growth of their business or businesses. So let's take a second and imagine when you're going onto Google, instead of just typing in a couple of words, you're actively uploading a picture and you're getting results back. Instead of just looking at someone wearing a specific outfit, you're getting search results that show you where you can buy it and what the competitors' prices are. These examples provide contextual, real-time data that is outside of the traditional text-based approach. And so what we're going to do is look at these different kinds of datas inside a data strategy that a software business or a large business with thousands and thousands of users on a daily or monthly basis might use in order to optimize what they're doing or just maintain data integrity. And so what we're going to talk about today are a few things. First, we're going to talk about what role data strategy plays inside of due diligence, mergers and acquisitions, scaling a business. Then we're going to move on to defining what are the traditional databases and data store strategies that are being used in most businesses today. This includes SQL versus NoSQL. And then what we're going to do is we're going to look at the definition of a vector database and how this is very relevant in the current age of AI, LLMs, and generative text. And then what we're going to do is look at some use cases and show you why this new sort of data is important. A business's data strategy is basically a plan for how the business is going to approach managing fulfillment, existing customers, and future insights. This is important because it helps the businesses understand how they're operating now, and it gives them an idea of how they're going to operate in the future. And so what exactly is a data strategy for a business? Now, what it usually is in the first stage, we're way past this, is some information comes in, it's put inside of some sort of spreadsheet, and then the people, they come over here and they look at it whenever they need information. As this goes on, usually there is a person responsible for maintaining these data sheets, and there are multiple people looking at them. Okay, then what happens as a business moves on is they start to get really fancy. They start to get automated data sources, and these are coming in from multiple places. Okay, this is coming in from customer service calls. This is coming in from their online data. This is coming in from their websites. This is coming in from every single place. And what's needed is a database. And what this database is it's a place where the data is stored, okay? And it is accessed from many different places. It's accessed from offices all over the world, and it can be accessed by any number of people. And what this provides is basically a universal source of truth. So that way everyone inside of the business is on the same page. And what happens as the business scales is now we have enough data that goes outside of these micro samples, a simple sample size, and we're able to really start to base decisions on this data. In the stage above, what happens is you usually have some sort of data scientist. This is supposed to be a tie, and we'll just say these are his arms and legs. And you usually have a data scientist and some sort of engineer that are both responsible for looking and maintaining after the insights that can be gleaned from this. It's a one-man team. But what happens as a business scales and it gets to thousands of people, thousands of users on a software site every day, it goes beyond the point that any human can manage this. And then what happens is they need to build what's called a machine learning pipeline. Or a more amateur version, a more naive version of a machine learning pipeline is just a data pipeline. And what happens is instead of having a team of people to manage the data and to glean insights, there are tools that are inside of software suites such as Google Cloud, AWS, or Microsoft Azure. I think this is the Microsoft Azure logo, like some sort of diamond. And this allows for teams to basically have teams of engineers look at this and glean even more information. So it's not just a universal source of truth, but it's universal inference. So people are able to get their own sort of ideas and unique insights from the same sort of data that meets their specific use case and need. So that is the high level of what a data strategy is. It gets much more complex with schemas and how we're going to actively manage all these different kinds of data. But what you need to know is that there are 3 kinds of databases. And usually it's reflective of the business structure or even reflective of whether it's a startup or not. So what we first want to look at is a SQL database. Now what a SQL database is it's like structured query language is what it stands for. These have been around for about 40 years and was really brought into the forefront of the business world with Oracle and whatever that guy's name is. And basically this allows you to define columns and rows that you can add conditional terms in order to access. These are great for scale, it's great for complex relationships, and it's great for getting information in a very maintainable way. Because as the data schema changes, as the kinds of data going into the business and output from the business evolves over time, migrations from one set of relationships of data to another is very easy. There's a universal query language that is used in order to access this data in different ways. What has happened over time is as businesses get very large, these relationships get too complex and they start to break down. If the business is very small, maintaining these relationships is very costly in terms of time and effort. So what has come out of that is a NoSQL database. And what this is basically just a nested text format. They usually refer to this in terms of documents and collections. So instead of having one unit over here that is users and another over here that is transactions, and you have to map a user to a specific transaction, what we're actually looking at is every user has a transaction nested beneath it. And these have worked well for a long time. It is the balance of robustness versus speed, complexity versus ease of implementation. But none of these really work very well when artificial intelligence comes into the picture. That's because artificial intelligence is a technology that is fundamentally different than anything that has come before. Where everything for the past 60 years of the internet has really been about managing the relationships between data objects, between users, what they're buying, how much they're paying for it, and the location, for example. What we're looking at now with artificial intelligence, machine learning, and large language models is statistical probabilities and the assignment of numerical values. And what this requires is a different method of search. So here's the thing, both SQL and NoSQL databases and data schemas, they struggle with AI-driven applications. Why? It's because they're not designed for semantic search, also known as search based on language. They're not built for natural language processing or deep learning models. So if you were wondering what semantic search is, NLP, natural language processing, go and look at my other videos and you're going to learn a lot about that and how AI is changing the way businesses scale and operate. So what the hell is a vector database? See, instead of looking for the exact words like a SQL database or a NoSQL database does, what it does is it looks for relevant vectors. What a vector is you can think of it as a token. You hear that when people talk about ChatGPT a lot. What happens is a word representation is turned into a mathematical representation that can then be calculated in these AI algorithms. And what this means is that a vector database, instead of storing these big, bulky words, phrases, and relationships, it just stores the mathematical representations of the data. So this means instead of a large language model taking your phrases and trying to force it into some words, it is basically taking a lower level approach. It is looking at the actual mathematical representation of your search query and the existing data and matching those using varying different search algorithms. If we want to go into more detail, these would be n nearest neighbor, k nearest neighbor, dot product search algorithms, but that's not really relevant right now. What is relevant is how AI-based search and natural language processing integrated with your business's data strategy can give you a big advantage. The advantage is basically looking at your data from a new perspective and getting insights and your first perspective from data that you maybe had not recognized before. Things like the language in a customer service ticket, the emails internally being shared between a business, how different sort of standard operating procedures can be searched and refined. Instead of having to break these down and get a team to put them into some sort of database or Notion or something like that, you're able to have your large language model go to exactly the place where that information is stored and get you not only quantitative information related to that, but qualitative information as well, which is very important when you're looking at how a business is currently operating and how it is going to integrate into other businesses or operations. So let's look at a couple of common examples. A really great one is search recommendations. You see, when you're on Amazon, Netflix, and YouTube, vector search is being used. It's going to recommend products, movies, and videos that are already similar to your viewing patterns. So how exactly does vector search work, just at a high level? When you are on Netflix or Amazon, and let's say you're looking for a movie that is horror, what the algorithm does is it'll basically break it down to a level that's a mathematical representation that is 0.27. Now, when it goes into the database, instead of having to say go through every single listing of videos, this is the entire list of videos in the storage base, and say, let's look at each one of these videos here. This is how the traditional search works. It finds one, and then it looks at more data here. It looks at more data here. What happens with a new vector database is it takes the entire data schema and it turns it into a mathematical representation. So instead of looking at movie titles, descriptions, the category label, it looks at thousands of different data points and it gives them different values, okay? And what it will do is it will look at the similarity or how near k nearest neighbor search each one of these values is. Now, while these two both will have the label of horror, there are other elements that it will look at. Maybe it's looking at the transcription, maybe it's looking at the search history, and you can see here that 2.7 is much closer to these vector representations. So it is allowing you, instead of going through 1 layer, 2 layers, 3 layers of search, which may take a while and may not even be so accurate, we're able to look at just the mathematical representation, do some numbers over here, and we're able to get something that is far more accurate and accessed much quicker with a much more fine-tuned search. And so when you know how these vector databases work, you can start to see how chatbots can start to work. If you can migrate your entire business's data schema from a traditional database and have a duplicate stored in a vector database, you're going to be able to have search functionality, common language queries functionality for most things in your business, instead of waiting for an engineer or a data scientist to go and run a report and extract that data and translate it in a way that a person understands. This is great for customer support. This is great for looking at different sort of fraud attempts or social engineering that could happen inside of your business. And so what are some misconceptions about this technology? Do vector databases replace SQL and NoSQL data strategies completely? No, they don't. There are very refined and very mature methods and business strategies and optimizations that are built specifically for traditional SQL databases, NoSQL databases, but relational databases in general. And this is what traditional business up until this point has been built off of. What a vector database allows you to do is to get additional insights and take a new approach to new data sets that maybe haven't been available to your business so far. And when you're able to get a new analysis, a new form of analysis and perspective to this data, there is also an opportunity to reduce the staff that was needed to perform that analysis in the past. Vector databases are only for big companies. This is false again. Now we have tools like Pinecone, ChromaDB, and even OpenAI that provide their own sort of infrastructure to put your data on vector databases. And some of these solutions are as cheap as $20 a month for hundreds of gigabytes of data to be stored and their embeddings to be translated. It's too expensive and complicated. This is not true. There are lots of open source tools, and there are even more platforms that are starting to spring up like Pinecone that allow you to use a no-code interface in order to upload your data and make it accessible to the different sort of AI integrations that you have in your business. So let's recap before my camera runs out of battery. SQL databases are great if you're running a big legacy system and you want your data strategy to be tried and true and part of, big traditional businesses. NoSQL databases built on top of JSON are great if you need to be adaptable, move fast, and you're not really trying to gain so many insights. A vector database is much more applicable when you're working with common language and you're working with data that would usually be difficult to manage using a traditional data source like SQL or NoSQL, or it would be too costly and robust to build a software application in order to get the kind of insights that you're looking for. Vector databases are usually faster and can process much more complex queries than you would be able to with a traditional data schema based on relational databases. So, what sort of databases are in your portfolio companies now? Do you think that vector databases can take them to the next level? Let's find out. If you're curious to learning how AI can be used in one of your businesses or it can be used to optimize operations across your portfolio, go ahead and give us a comment, send us a message. That's really what we specialize here in Rock Studios. And stay tuned for our next videos where we're going to show you how you can use AI to optimize your portfolio, cut expenses, cut staff, and really reach that growth stage that you're looking to hit much faster and with less effort. Thanks for watching.